Welcome to another exciting episode where we delve into the intriguing world of military technology. Today we're exploring the physics behind Russian tanks and their sky-high turrets. Before we dive into this fascinating topic, ensure you're subscribed to our channel so we can continue providing you with intriguing content. We're about to peel back the layers of a peculiar phenomenon. Ever wondered why Russian tank turrets fly so high when they're shot at? It's not just an explosive spectacle, but a complex interplay of design, physics, and the raw power of military technology. Stick around and let's unravel this military mystery together. To understand why Russian tank turrets fly so high, first we must understand what happens when a tank gets hit. So let's dive into the world of military hardware, shall we? When a tank is hit by ammunition, the kind of damage it sustains depends largely on the type of ammunition used. Two types that commonly come into play are armor-piercing and high-explosive rounds. Armor-piercing rounds, as the name suggests, are designed to penetrate a tank's armor. They're like a hot knife through butter, cutting through steel and wreaking havoc inside. When an armor-piercing round hits a tank, it's not the explosion that does the most damage, but the shock wave. This shock wave travels through the tank, damaging internal components and often proving fatal to the crew inside. On the other hand, high-explosive rounds are designed to cause a large explosion on impact. Rather than penetrating the armor, these rounds aim to cause as much damage as possible to the exterior of the tank, with the resulting explosion potentially damaging or disabling the vehicle. Now, a tank's armor is its first line of defense. It's designed to withstand the force of explosions and protect the crew inside. Modern tanks often have composite armor, a combination of different materials designed to absorb and deflect the energy of incoming rounds. The thickness, angle, and composition of this armor can mean the difference between a minor dent and catastrophic damage. But no matter how strong the armor, the force of an explosion can cause some unexpected results. When a tank's armor is hit, it's not just about the damage caused by the round itself. The force of the explosion can cause the tank to move, and if that force is directed upwards, it can result in the tank's turret being launched into the air. This is where we start to see why Russian tank turrets fly so high, but we'll delve deeper into that in the next scene. Until then, remember that in the world of tanks, it's not just about the armor you have, but how you use it. Now let's delve into the unique design of Russian tanks, which plays a crucial role in this phenomenon. Russian tanks, known for their robustness and reliability, have a distinct design that sets them apart from their counterparts. The heart of this design is the turret and the ammunition storage. The turret, the revolving gun tower on top of the tank, is meticulously crafted for optimal performance and protection. But what makes it truly unique is its auto-loading mechanism. Unlike most Western tanks that require manual loading, Russian tanks employ an autoloader. This mechanical system loads the tank's main gun automatically, allowing for a faster firing rate and a smaller crew. This ingenious design is not without its drawbacks, however. The autoloader and the ammunition storage are both located in the same compartment, right underneath the turret. This arrangement is space-efficient but poses a risk in case of a direct hit. If a penetrating round manages to reach the ammunition storage, the result is a catastrophic explosion. This explosion, due to the confined space and the proximity of the ammunition, has nowhere to go but up, lifting the heavy turret off its mount and sending it soaring into the air. The turret's weight and the force of the explosion combine to create the spectacular sight of a flying turret. The placement of the autoloader and ammunition storage is a calculated risk. The Russian design favors speed and efficiency, and while the potential for a flying turret is indeed a risk, it's a risk deemed worth taking. The design reflects a philosophy of aggressive, fast-paced warfare, where the ability to fire quickly can mean the difference between victory and defeat. So, while it's a sight to behold, the flying turret is a direct result of a design choice, a choice that exemplifies the trade-offs inherent in tank design, and indeed, in warfare itself. The design of Russian tanks, particularly the turret and ammunition storage, plays a significant role in the height of the flying turret. Now that we have the basics, we can delve into the physics behind why Russian tank turrets fly so high. The first thing to understand is the principle of conservation of momentum. For those who need a quick refresher, this principle states that the total momentum of an isolated system remains constant if no external forces act on it. In the case of a tank, when an explosion occurs within the hull, the force of the explosion pushes outwards in all directions. But due to the sturdy design of the tank, the only part that can move freely is the turret. This is where the conservation of momentum comes into play. The momentum before the explosion, which was zero, is still zero after the explosion. However, now we have a large force acting on the relatively light turret in one direction and an equal and opposite force acting on the much heavier hull in the other direction. The result? The turret is launched skyward, often several meters into the air. The momentum of the turret flying upwards and the hull moving slightly downwards balances out, keeping the total system momentum at zero. Another critical factor is the rapid expansion of gases. When the ammunition inside the tank explodes, it rapidly turns into a high-pressure gas. This gas needs somewhere to go, and the path of least resistance is usually upwards through the turret. This rapid gas expansion adds an extra push to the turret, sending it even higher into the sky. And let's not forget the role of the tank's design. Russian tanks, in particular, have a reputation for their turrets flying high upon explosion. This is largely due to their distinctive turret designs, which tend to be lighter and less securely fastened than those of other tanks. This makes them more susceptible to being launched into the air by an internal explosion. As we can see, it's a combination of design and physics that leads to these dramatic scenes. Now that we've unraveled the mystery, let's discuss the implications of these flying turrets. The spectacle of a tank turret soaring through the air isn't just a visual marvel. It's a stark reminder of the immense power and potential danger at work. When a turret is launched skyward, it doesn't just pose a risk to the tank and its crew. The danger extends to those nearby, particularly infantry. Picture a heavy metal turret weighing several tons, propelled into the air by an explosion. It becomes a massive, unguided projectile that can cause significant damage wherever it lands. This is why the positioning of tanks in a battlefield is so crucial. To minimize the risk of collateral damage, the tank crew themselves are at great risk. It's important to remember that inside these armored beasts are human beings. A turret detachment often means a catastrophic kill. That's military jargon for a hit that not only takes the tank out of action, but also endangers the crew's lives. That's where the design of the tanks comes into play. A well-designed tank can help in reducing these risks. The Russian tanks we've discussed have blowout panels designed to direct the force of an explosion upwards, away from the crew compartment. This design is aimed at improving crew survivability in the event of a catastrophic hit, yet it's not fail-safe. The crew still faces a perilous situation. They must evacuate quickly before the tank turns into a deadly inferno. Surviving a catastrophic hit is not just about good design, but also about the crew's training and readiness. While it's a dramatic sight, the flying turret is a reminder of the powerful forces at work in tank warfare. It's a testament to the destructive power of modern weaponry and the constant need for advancements in tank design and crew safety. The flying turret is not just a spectacle, but a lesson in the harsh realities of modern warfare. As we wrap up our discussion, let's summarize what we've learned. We've delved into the world of tanks and uncovered some fascinating facts. We started off by understanding the catastrophic results when a tank is hit, especially the explosive force that can cause extensive damage and often sends a tank's turret flying. We then focused on the distinct design of Russian tanks, which are a testament to their engineering prowess. Their compact design, coupled with their unique ammunition storage, contributes to the high-flying turrets we often see in footage. Next, we explored the intriguing physics behind these flying turrets. It's all about the perfect storm of pressure, heat, and explosive energy. When a tank is struck, the internal explosion creates an immense pressure buildup. Unable to escape quickly enough, this pressure pushes the turret upwards and sends it soaring into the sky. We also discussed the impact of these flying turrets. While it's a spectacular sight to behold, it also serves as a grim reminder of the destructive power of military weaponry. Our journey into the world of tanks and the high-flying turrets of Russian tanks has been truly enlightening. But remember, there's always more to learn and more to explore. Remember to like this video and subscribe to our channel for more intriguing content like this.